Hello, everyone, and thank you for joining me today. My name is Bhaskar Sawant. I am a senior .NET developer and team lead. I am also an IEEE senior member with the Southeastern Michigan section. Over the past 15 years, I have been working on CI/CD pipeline, DevOps automation, and enterprise scale software delivery systems. Today, I want to talk about the shift that is quietly but fundamentally changing our industry, how the software is written, how it is delivered, and how it must be secured. The title of this session is Shift Left, Shield, a DevSecOps playbook for AI era CI/CD pipeline. This is a practical blueprint for securing the modern pipelines without compromising the speed. In the last few years, tools like GitHub, Copilot, and ChatGPT have moved from being experimental helpers to everyday development companions. They write code, generate tests, create scripts, and even suggest the infrastructure configurations. That acceleration is exciting, but it also introduces a new reality. Our pipeline are now trusting the code that no single human fully wrote or reviewed end to end. So the question I would like to us to explore today is simple. How do we secure the software when the software is increasingly written by the machines? For decades, software security was built on a basic assumption. Code is written by the humans. We hired the developers, trained them, received their codes, and held them accountable. Today, that assumption has changed. AI assisted coding and automated code generation have fundamentally transformed the software development. Tools like GitHub, Copilot, and ChatGPT now write the significant portion of the production code. This dramatically accelerates the delivery, but it also introduced the security challenges that traditional DevSecOps practices were never designed to handle. The attack surface has expanded beyond the human written code. AI generated snippets, automated dependency updates, and machine learned configuration now flow through the pipelines, often without the scrutiny they deserve. Understanding these new threats vectors is first step towards building the resilient and the secure CI/CD system in the AI era. This slide highlights the new risk that comes with the AI assisted development. First, prompt injection attacks. Malicious actors can manipulate the AI coding assistant through the carefully crafted comments and documentation, causing them to generate the vulnerable code or expose the sensitive data. Second, training data poisoning. AI models trained on a public repositories may learn and reproduce the insecure patterns, duplicated libraries, or even the hard-coded credentials that slip into the training data. Third, automated dependency confusion. When AI suggests package names, attackers can exploit the typo squatting to insert the malicious libraries directly into the build pipeline. And finally, obfuscated malicious code. AI generated code reviews may miss the sophisticated obfuscation techniques that experienced the human reviewers would normally flag. These risks are not hypothetical. They are already appearing in the modern software supply chain attacks. The impact of the previous slide mentioned risk is already visible. The recent industry research shows that 78% organizations have experienced at least one software supply chain security incident in past years. At the same time, AI tools now generate an estimated 40% of a new enterprise code. That means potential blast radius of compromised AI assisted workflow has never been higher. Traditionally, security gates catch known vulnerabilities, but they are blind to the subtle risk embedded in AI generated code. The real challenge today is not just preventing that bad code, it is ensuring the traceability, maintaining the provenance, and building the confidence in an increasingly automated development workflow. In simple terms, we must prove what we deploy is what we intended to build. This brings us to the foundation, shift left security. Shift left means embedded security directly into the development workflow instead of adding it at the end of the pipeline. This slide highlights the three key principles: secure by design, embedding the security directly into the development workflows; early detection, identifying and remembering the vulnerability as early as possible; automated enforcement, automating the security policy enforcement. Shifting left means protection is built into every development phase, from real-time code scanning to dependency validation, making security strong yet seamless for the developers. The goal is simple. Security should feel natural to the developers, not like an external checkpoint. When done correctly, developers move fast and security keeps pace silently in the background. To test the software, we must know exactly what goes into the every build and where it came from. This slide combines two critical ideas: software bill of materials, means SBOMs, and build provenance. First, SBOM generates the comprehensive machine readable list of every dependency and build time to use to build it. When SBOMs are generated automatically and integrated with the vulnerability databases, we gain the immediate visibility into the supply chain risk. Policies can then enforce which components are allowed into our pipeline. Second, build provenance uses the SLSA frameworks to create the verifiable records of who built an artifact, when it was built, and under what condition. Signed build attestations are immutable. Go long ensures the artifact reaching the production is exactly what was built, with no tampering in between. In simple terms, SBOMs tells us what is inside, provenance tells us where it came from. Together, they establish the trust in a software delivery. Once we have the visibility and the provenance, we need consistent enforcement. Policy as a code frameworks define the security requirement as a version and testable code. We define the policy in a code, we test the policy logic in a CI/CD. We enforce the policy at commit, build, deploy, and runtime. And we audit and refine them over time. This ensures the security enforcement is consistent, repeatable, and automated without slowing down the developers. Security becomes engineering, not the paperwork. Build systems are high value targets. If attackers compromise a built environment, they gain the perfect position to inject the malicious code into every artifact we ship. Hardening requires the multiple layers of defense. Container isolation ensures each build runs in a clean, unparalleled environment with the minimal privileges. Infrastructure as a code makes the build configuration auditable and reproducible. Artifact signing creates the cryptographic proof that the artifacts hasn't been tampered with after the build. Together, these controls significantly reduce the build system risk. This slide shows how infrastructure as a code strengthens the security. Build environments should be destroyed and recreated for every job, preventing the persistent compromises. Build processes must follow least privilege access using the scoped credentials and real-time or time-limited tokens. Network should be segmented, isolating the build system from production and limiting the external connectivity to the approved sources. These controls prevent the persistent attack and limit the lateral movement inside the infrastructure. Modern CI/CD platforms run builds is disposable container environment. This prevents the attacker persistence and limit the blast radius if the build is compromised. Complementing the isolation, artifact signing using loop tools like cosign or sign store establish the cryptographic proof that artifacts hasn't been tampered with after the build. Only verified and authorized artifacts proceeds through the pipeline into the production. Key insight: isolation limits the blast radius, signing provides the verifiable provenance. Together, they provide the defense in depth for software supply chain. Security is not only about the prevention, it is also about the detection. This slide shows the monitoring across the pipeline. At the code commit, scan code and validate the signature. At the dependency resolution, verify the checksum and detect the typos correctly. At build execution, monitor for anomalies and exfiltration. And artifact publishing, validating the SBOM and provenance. At deployment, enforce the signature and policy checks. This creates the continuous visibility across the entire software lifecycle. Here we see the real world indicators of supply chain manipulation. Behavioral anomalies such as unusual build duration, unexpected network traffic, or unauthorized changes to build the scripts. Technical indicators such as unsigned commits, mismatched package checksums, missing SBOMs data, or artifacts without valid provenance. These patterns allows teams to detect manipulation attempts before they reach the production. For DevSecOps to be sustainable, security must be fast, automated, and seamlessly integrated. We shift security into the IDE so issues are caught before the commit. We parallelize security scans with the functional test. We provide the actionable feedback so developers know exactly how to remediate the problems. This ensures a strong protection without blocking the developer's productivity. A strong security program is measurable. We aim to detect the issues in under 2 minutes, remediate the vulnerabilities in under 10 minutes, maintain nearly 100% artifact signature coverage, and achieve zero supply chain incidents in production. These metrics demonstrate how security enhances delivery velocity through the automation and fast feedback. These slides summarize the practical approach. Start with SBOMs and provenance, implement the policy as a code, harden build systems, monitor for anomalies, and measure and iterate. Security posture must evolve to match the AI assisted, automated, and faster software delivery. AI assisted development is here to stay. Automation will only grow. That means our security practices must evolve with it. When we shift left, we build the security into the development. When we shift right, we protect the production with the verifiable trust. This is how we move fast without losing the confidence, integrity, or trust. Thank you so much for your time. I truly appreciate your attention today. If you have any questions, thoughts, or would like to continue this conversation, this is my LinkedIn profile. Please feel free to connect with me. I would be happy to stay in touch. Thank you so much.